Hi, I'm Arepalli Srinivasa. I'm from Data Structures and Algorithms class. Today I'm going to explain about parallel matrix multiplication. Introduction to the parallel matrix multiplication. Parallel matrix multiplication method is the performing the multiple matrix multiplication by disturbing the computational work across the multiple process or cross allowing the for the signification faster executing by stimulating the calculations different parts of the relaxation matrix on different processing units, making use of the inheritance parallel in the operations where the most calculations for each element's output matrix are independent of each other. Key points about the parallel matrix multiplication. Independent calculations, data penetrations, computation overhead. Intro to the matrix multiplication. In mathematics, significantly in the linear algebra, multiple matrix is the binary operation that produces the matrix from two matrices. From the matrix multiplication, the number of columns in the first matrix must be equal to the number of rows in the second matrix. The resultant matrix, known as the multiple product, has the number of the rows of the first number of the columns of the second matrix. The product of the matrix A and B is denoted by the A and B as 1. Multiple matrix was first discovered by the French mathematician Jacques Fillon Maurice Bernet in 1812 to representing the compositions of the linear maps that representing the matrices. Matrix multiplication is the basic tool of the linear algebra, such as numeric applications in the area of mathematics as well as applied mathematics, statistics, physics, economics, and engineering. Computation mathematics is the central operations in all the computation algorithms of linear algebra. Benefits of the parallel matrix multiplications: faster computation, scalability, machine learning, signification computers, image processing. By utilizing the multiple matrix, overall the time required the multiple matrix can be significant reduce the efficiency of the large matrix. Parallel algorithms can be updated to work the significance with the various number of processes. In the real life, multiple matrix multiplications are used across the various fields like physics, engineering, economics, computer graphics, and data analysis, representing the multiple complications data sets, solving the system's linear equations model, real-time phenomena, and performing the calculations, imaging, processing networks, analysis, even the encryption. Parallel matrix multiplication is used in the computer systems like image processing, cyber photography, cryptography, machine learning, economics and finance, modeling, portfolio organization, supply and chain management, population analysis, and social networking analysis. These are mainly used in Google search and GPS navigation and weather forecasting. Step by step process of the matrix multiplications. This Python program efficiency performance parallel matrix multiplication using the thread pool executor from the current features modules instead of manually managing the shared memory or synchronizations. This implementation uses the thread based parallelism into compute the each row or individually by learning linearing numpy optimizing dual product functions. The program use fast and correct calculations. The program first initializes the empty matrix for the result, assigns the computation of the each row to separate the threads, and finally combines the result into the final output. This approach provides the correctness, simplicity, and efficiency without requiring the complex memory management. Step 1: Input required libraries. Import the numpy in NP. From the current features, import the threadpool executor. NumPy used in handling the matrix or operations efficiently. Thread pool executor manages the parallel executor of the task using threads. Step 2. Definition the functions of the current compute row of the result matrix. Definition of the computer row result Rambutan computant product dot do I. This function that calculates the dot product of the row I from the matrix A and B. Mm, Since each row C is independent, this function allows the parallel computing without issues. Step 3 defines the matrix multiplication function. Defines the parallel matrix multiplication A and B. Num row is equal to the shape of A is of 0. Num of the row is A. C is equal to num NP of the 0 and num rows B shape 1. Initializing the result matrix. Uses the thread pool matrix for the parallel computing without the thread pool row executor as the executor. Result is equal to executor map lamp computer I row of 1 comma a comma b. Range of the number is equal to row. Store the computing row in C. For I comma row in the executing result, C of I is equal to the row. Return to the C. Step 3 initializing the result matrix. C is equal to NP0 row, num is equal to row B of shape. This creates the empty row 0 matrix, requires the diminutions row into the column. Uses the thread pool matrix computation each row in the parallel with thread pool executor as an executor. Result is equal to executor map lambda I computing a row is equal to a comma b comma c. Range is equal to num row. Executor assigns the each row to the separate thread. This function compute row comma I comma a comma is called as each row in the parallel. Performance analysis of the parallel matrix multiplications examines how efficiency of a matrix multiplication operation can be executed across the multiple process. Considering the factors like computing time, communication overhead, data distributions, and size of the matrices, with the goal of the maximizing the speed of efficiency utilizing the parallel process capabilities across the pros nodes and computing systems. Key aspects of the performance analysis for the parallel matrix multiplication. Computing the complex inherit the compute of the matrix multiplication where the n is the matrix divisions and meaning the computations time increase the capability with the matrix size. Data distribution, how the raise of the data distribution, column wise distribution, block wise distribution. Communication overhead, the time spent to transfer the data between the processor and during the computation is the critical factor eligibility of the large matrix. Gradually the size computation task with the larger granularly meanings the less communication overhead relative to computation. Conclusion of the parallel matrix multiplication. The final result is a new multiple matrix whose the diminution and determined by the number of rows in the first matrix and the number of columns in the last matrix. With the curriculum conditions, the number of columns and each immediate matrix must match the number of the rows in the next matrix. Key points about the multiple matrix multiplication: determination of the capabilities, order matrix, resultation uh, determinations. Program efficiency, parallel matrix multiplication using the threads, not processing, avoiding the memory sharing issues. Each thread's a computation number of rows result the matrix independently, reducing the overhead and improving the performance. Using the NumPy Z dot plotted, and the program executed the fast computation. The approach in the scalable meanings is in handling the larger matrix efficiency by increasing the number of threads. No complex compression sharing the locks is needed, making this simple, reliable, and effectivity.